Okay, let's talk about F5. The first thing about F5, they give you a graph. It's a graph of G prime. They talk a little bit about G, just sort of telling you that it's defined differentiable, and they give us a point on G. But remember, this is the graph of G prime. Okay, so what do they want? They want G of 3 and G of negative 2. So how do I go from a graph of the derivative, or you could think of this as the rate of change of g. How do I go from g prime to g? Well, I'm not going to think of the slope of this graph. That would give me g double prime. I need to think about the area underneath this graph. Now, when you start talking about area, it's a little bit complicated. And so thinking about part A is really helped by thinking about the fundamental theorem. So I've written that down here, at least this one that I'm talking about. We don't usually see it this way, but what this says is, well, how do you find a definite integral? By the fundamental theorem, you can find the definite integral by finding an antiderivative and then plugging that bound in to the antiderivative and subtracting. Well, what's the antiderivative of g prime? Well, g prime is the derivative of g, so the antiderivative of g prime is g. So it makes sense that the antiderivative from 0 to whatever number, the definite integral, I should say, from 0 to whatever number of g prime is just what g at whatever number you want, this x and that x are the same, minus whatever g of 0 is. Now I cooked this up because I know the fundamental theorem, but this is going to find me g of x. All I need to do is add g of 0 to both sides, and I've got g of x equals g of 0 plus this definite integral. You want g of 3, you just plug 3 in for x there and plug 3 in for x there, and you'll get g of 3. Now how do you find this definite integral? You're going to have to find it using some area formulas. I see a circle, I see a triangle, that kind of thing. So the fundamental theorem really does help think about this first part A problem. So g of 3 is 5. Oh, by the way, how did I know to start at 0? Remember, I know what g of 0 is. It's 5. So that's where this 5 comes from, 5 plus the definite integral. How'd you find that definite integral? Well, there's a quarter of a circle, I think. Is that right? Yes. And the area of a triangle. There you go. G of negative 2, the only thing that's tricky about g of negative 2 is that this area from 0 to negative 2, the area of this half circle has got to be negative. Even though that area is above the x-axis, you're integrating from right to left, so that makes it a negative number. So this definite integral from 0 to negative 2 has a value of negative pi. All right, next, part B, find the x-coordinate of each point of inflection. I think this is an easier problem than part A. How do you find points of inflection for a function? You have to look at the second derivative. Points of inflection happen where the second derivative changes sign. Well, how is the second derivative related to this graph right here? Well, this is the graph of g prime, so the slope of this graph gives you g double prime. The slope of this graph gives you the derivative of this graph, and the derivative of this graph right here is the derivative of g prime, which is g double prime. So this question really is asking, where does this graph change slope? Or better put, where does the slope of this graph change sign? From positive to negative or from negative to positive? They also say it, they say it a different way, which is perfectly fine. They talk about where does this graph change from increasing to decreasing. That's the same thing as saying where does the slope change from positive to negative. And by the way, the other way, from negative to positive slope or from decreasing to increasing, also signals a change in sign of g double prime, which in turn indicates a point of inflection, at least the x-coordinate of a point of inflection. All right, so where does this change from positive to negative? Where does the slope of this change? Well, right there, that changes from positive slope, negative slope. This has a negative slope and a positive slope, so the slope changes sign there, and the slope changes sign there. You have to know enough to know to look at the slope of G prime. Finally, part C. H is a function defined like this. Find the x-coordinate of each critical point of H. Well, let's start there. To find the critical points of H, you need to find the derivative of H and set it equal to 0. What's the derivative of H? Well, the derivative of H is the derivative of G minus the derivative of this thing, which is just x. So G prime minus x equals 0. That's looking for the critical numbers now. Where does G prime equal x? Well, that's tricky. This is the graph of G prime. So where does the y-coordinate of this graph, where do y points and x points, where are they equal? That's what this is saying. G prime of x, that's the y-coordinate on this graph. Where is the y-coordinate and the x-coordinate equal? Well, this point jumps out right away. So G prime at 3 is 3. So G prime of 3 is equal to x. 3 equals 3. The other one is quite a bit harder to get. You'll notice this circle is centered at the origin, which means there is a place right there where the x and the y coordinate are equal. There's actually two places where the absolute value of the x and the y coordinate are equal. Right there and about there. I messed up the drawing a bit. But there, over here, the x value is negative and the y value is positive. So G prime doesn't equal x there. G prime equals the opposite of x. But right here, at a 45-degree angle, or pi over 4 angle, that's where this happens. This is radius 2. So these are the points root 2 over 2, root 2 each. When x equals root 2, y equals root 2. The other way to do it, the way they did it, is they actually fit that part of the circle with the function. That's the top half of a circle centered at the origin with a radius of 2. And then they said, okay, where is G prime equal to x? They solved that, so on. Either way, that one's tricky to get. It really is. So anyway, part C was a little bit tough to get all of it, but at least the first part, at least seeing this point, is should be well within your abilities if you can sort out what it is they're actually asking for. So that is that's F5.